Hey guys, so I'm making a video on the lecture that we did today. We already got through this part, so I'm just going to skip over to the more confusing parts. Okay, so for this one, I was looking at it, and on your notes, we actually did this wrong. So, what is the length of the wooden stick? It depends on the units. So, this is actually the correct answer. I think in class we said it was this one, but it's not. But it's just because of the units. So right here, you see that it's at 4, and then it's just a little bit past the 5 point. So these lines represent the tens place. So the numbers in the halves, that's the tens place. All these little lines in between, these are the hundreds place. So on this specific ruler, we have accuracy up to the hundredths place. So here, we know that this is 4.5, and we know that this is between 4.5 and 4.6. So, let me write this down. So it's 4.5. So we know that it is greater than that, but it's less than 4.6. And since we know that, and these marks are in the hundredths place, this could be the only possible answer. This answer is in the tens place. That would work if we only had these lines right here. But we have additional lines that gets us to the hundredth place, and that's why this is the answer. So there's some confusion about the rules as well. So remember, 0 is in the middle of a number. Sorry, we forgot to read this part. When reading a measured values, all non-zero digits should be counted as significant. So if it's a non-zero, if it's just a regular number, it is significant all the time. These are rules for zeros. So the first zero rule is if a 0 is in the middle of a number and any other significant digit, they are always significant. So we said the sandwich zeros if they're sandwiched in between two significant figures, then they do count. And that's why this guy has 1, 2, 3, 4, 5 significant figures in the answer, as opposed to the zeros not counting. The second rule is the zeros at the beginning of a number are not significant. So even if there's a decimal point, if they're at the beginning of a number, they're not going to count. So these two don't count. So this guy does, and this guy does. So that's why there are 3 significant figures in this answer. This guy has 4 significant figures. These 4 are the 4 significant figures because this 0 follows the first rule where it's sandwiched in between 2 significant figures. But these 2 in the front don't count. So whenever they're in the front, they don't count. Rule number 3, the zeros at the end of a number after the decimal point are significant. So these are at the end of the number. So this one would have 1, 2, 3, 4, 5, 6 significant figures. And then the last rule, which is the most confusing rule, I think, that confuses in class, zeros at the end of the number and before an implied decimal point may or may not be significant. We cannot tell whether they're a part of the measurement or whether they act only to locate the unwritten implied decimal point. So here's an example of that. If we have a number that's, let's say, 42,000, this number would actually only have 2 significant figures. These zeros don't count, even though the third rule is that if there's zeros on the end, they're significant, because these guys are called placeholders. They don't have an assigned value. They're just there for the decimal. However, if it had been written like this, 42,000 decimal point, then we know that that decimal point is there for a reason, and we can count 1, 2, 3, 4 significant figures for this one. So if it's an implied decimal point, meaning you know that this is 42,000 and there should be a decimal point here and there isn't, they don't count. But if they do have a decimal point, then they do count. So in this example, all these digits are non-zeros, so there's 6 significant digits because they all count. This one, the beginning zeros don't count, 1, 2, 3, so we're left with these 3 significant figures. For this one, there's 5 significant figures because the ones at the end do count. The decimal point is here. There's an actual decimal point. It's not implied, so the trailing zeros do count here. However, the ones in the front do not. So we have 1, 2, 3, 4, 5. For this one, we also have 5 because there is a decimal point. There are no implied decimal points here. So it's 1, 2, 3, 4, 5 because these zeros are at the end. For this one, there's an implied decimal point, meaning we can't determine whether or not these are valid. So we only have 2 significant figures that count as valid. For this one, if it's an exponential form and it doesn't tell you to change it into decimal form, you just count whatever the decimal point is here. So all of these are non-zeros, so all 4 of them count. This one, there's 6 because these zeros are sandwiched in between these 2 significant numbers. And then remember, zeros at the end also count. So there's 1, 2, 3, 4, 5, 6 in this one. Scientific notation we covered last year, so that shouldn't be much of a problem. But there are some examples that I want to show you that are in later slides. So you guys should know how to do exponents, positives, and negatives. And I'll show you some examples right now anyway. However, let's see, rounding off numbers. That's on your assignment today. It says, when we're doing arithmetic on a pocket calculator, the answer is displayed with 1 or more significant figures that are really justified. So how do you decide how many digits to keep? There's simple rules. So rule 1, if the first digit you remove is 4 or less, you're going to drop down. So it's basically the rounding rules. If it's 4 or less, you're going to round down. And then the second rule is if the number is 5 or more, you're going to round up. Okay, so this one says make the following into 3 significant figures. So on this one, we currently have 5 significant figures and we need to make it into 3. So we're going to focus on the 3rd significant figure in this one. We're going to look at the number right next to it. This is above a 5, so according to our rounding rules, we're going to round up. So we're going to round this up to 150 or 1.56. And that'll be our rounding to 3 significant figures. This guy, remember, the first zeros don't count. So in order to get it to 3 significant figures, you're going to focus on where the significant figures start. So it's these 3 guys. This number 2 is below 4, so we round down and we keep it at 0.00374. This one, they're all significant because they're all non-zeros. We're going to focus on the 3rd one because we want to round to 3. This 7 right here is above 5, so we're going to round up, and our number is going to be 1370. And it might look confusing because this might look like there's 4 significant figures, but remember, there's an implied decimal here. So if there's an implied decimal, that means that this 0 doesn't count. Had there been a decimal here, then there would have been 4, but since there isn't one, there's 3. For this one, we're going to focus on the 3rd one. This is 5 or above, so we're going to round up, and our final number is going to be 129. And again, there isn't 6 significant figures here. There's only 3 because there's an implied decimal here. Here we're going to focus on the 3rd significant figure, which is this one. The 8 is above 5, so we're going to round up. So it's going to be 1.67 times 10 to the 6th power. And then there's rounding to 4. So this one we would focus on the 4th number. So this one is 4 or less, so we're going to round down. And it's going to be 4965. For this one, we're going to focus on the 4th number, which is the 5th one. The one right next to it is an 8, so it's above 5, so we're going to round up. So it's going to be, this is going to turn into a 6 because we rounded up. This one, the 4th significant figure is right here. This is 5 or above, so we're going to round up. So this changes the whole thing to 2,000. We need to put the decimal here in order to have 4 significant figures. Remember, in this one, this isn't 6 significant figures, it's 4, because these last 2 zeros don't count because it's an implied decimal. When you're working with problems, when you have multiplication, division, addition, subtraction, there's one rule. The answer cannot have more significant figures than either of the original numbers. So you're going to look for the lowest significant figures. So here's a division problem. And then once they divide it, they ended up getting this answer. However, the original number here has 3 significant figures. This one has 4 significant figures. So you're going to go with the lowest amount of significant figures, which is 3. And that's how many significant figures your answer should have. And you're going to use the rounding rules to determine the last digit. For addition subtraction, there's a decimal rule. So it says it cannot have more digits after the decimal point than either of the original numbers. So the original number here is 3.18, and then the number here is 0.013. The lowest number is this one. This one goes to the hundredths place. So your answer should end up in the hundredths place as well. So you can't go past 3.19. If you were to put 3.91 or whatever, that would be wrong because you need the same number of decimal places. So here are some examples of multiplication and division. So these two guys, when multiplied, they ended up getting this answer. This answer has 3 significant digits, and it's because the lowest number here has 3 significant digits. This one has 4, but you always go with the lowest amount of significant digits. This one is division, so the same thing. This number has 1, 2, 3, 4 significant digits. This one has 3. So your answer should also end up with 3 significant digits. That's why they end up with this. This one has 1, 2, 3, 4, 5, 6 significant digits. This one has 4 significant digits. So your answer should end up with 4. So these 4 are significant digits. Remember, zeros in the front do not count. This one, the lowest number of significant digits is this one. This one has 1, 2, 3, 4. This one has 1, 2, 3, 4, 5, 6. So your answer needs to end up with 4 significant digits. This one, the lowest one, they're 4 each. This one is 4, and this one's also 4. So your answer is going to end up with 4. And you can see that over here on this answer. Okay, for addition subtraction, you're going to focus on the decimal point. So this one is 25.5, so this one goes to the tens place. This is 34.270. So this one goes to the thousands place. So you can't go past the tens place because the lowest number ended at the tenths. So we end up with 59.8. For this one too, this one ends in the hundreds place for this one. So we can't go past the hundreds. So even though we got this number, we're going to round it to the hundreds place. This one has no decimal place. It doesn't go to the tens or the hundreds. So our answer is going to end with no decimal point value. Okay, for a mixed order of operations, you need to work out the problem, and then you need to figure out whether you're going to end up with addition, subtraction, or multiplication, division, and use that rule. So this is 8.52 plus 4.1586 times 18.73 plus 153.2. So the way we're going to work this out is we're going to multiply 4.1586 times 18.73 and then add up all those values together. Now when we add them up, remember for addition and subtraction we need to follow the decimal point rule. So the smallest decimal point value here is the 0.2. This is in the tens place, and these two guys are in the hundreds place. So our answer needs to end up in the tens place. So here we round down, and we end up with 239.6. With this one, it's addition, and then multiplication, and then addition. So we need to add these two guys together, add these two guys together, and then multiply them. So we end up with a multiplication problem. And then for the multiplication problem, you need to end up with the smallest amount of significant figures. This one has 4. This one also has 4. So our answer should end up with 4. And that's it. If you have any more questions, you can email me. That should help you with your assignment today.